In this video, we are going to talk about balancing of redox equations in basic medium. And we are going to be using half equation method. Half equation method. Just like we did in the previous video, where we use half equation method to balance redox equation in acidic medium, we are going to follow similar steps to balance in basic medium. Recall, the first step is identify the medium of reaction. And here, the medium of reaction is basic. And then the next step is to balance the equation atomically. That is, we balance the number of atoms at the left-hand side and right-hand side of the equation. So how do we do that? You're going to balance the central atom first. Balance the central atom. Then balance each oxygen atom by H2O at the other side, just like we did for acidic medium, but there is something that will be particularly different for this basic medium. Balance each oxygen atom by H2O at the other side, then balance each hydrogen atom by H plus at the other side. Yeah, remember this. So the next step, like we know, is to balance the equation electrically, just like we did under balancing for acidic medium in acidic medium. So that means you balance the number of charges such that the total number of charges at the left hand side of the equation should be equal to the total number of charges at the right hand side of the equation. Now, this is what makes balancing of redox reaction different in basic medium. Because we have basic medium, by the time you get your net ionic equation, as though you balanced in acidic medium, you are going to look for, check the number of H plus present and add the corresponding number of OH minus to both sides of the equation. So let's say after you balance the equation following these 3 steps above, then you arrive at a net ionic equation as if you balanced in acidic medium. Now, to convert it to basic medium, then you follow this 4th step. To convert it to basic medium, you check the number of hydrogen ion present and add the corresponding number of hydroxide ion to both sides of the equation. As simple as that. So let us consider this example. Balance the equation below in basic medium. Chromium 3 plus BrO minus gives CrO42 minus plus Br minus. So we are going to be using half equation method. And then, like we said, let's identify the oxidation and reduction half equation. Here, chromium is going from +3 to +6. If you calculate the oxidation number of chromium here is +6. So chromium is going from +3 to +6. Definitely that is oxidation. So we can have Cr3 plus goes to CrO42 minus and call this oxidation. And the second half equation, Br is going from +1. If you calculate the oxidation number of Br here is +1 to -1, definitely that is reduction. Br O minus gives Br minus, that is reduction. So let us balance the equation atomically. Balancing the equations atomically. The rule says that we should balance the central atom first. For the oxidation part, the central atom is already balanced because we have one atom of chromium, one atom of chromium. So let's balance the oxygen atom. So here we have 4 atoms of oxygen. Remember that the rule says that balance each oxygen atom by H2O at the other side. So we are going to balance. Here we have 4 oxygen atoms, so we are going to add 4 H2O to the other side, which means the equation will become Cl3 plus 4 H2O gives CrO4 2 minus. Now there is a problem. We've introduced hydrogen to the equation. How many hydrogen atoms do we have here? 4 times 2, that's 8 atoms of hydrogen. The rule says that balance each hydrogen atom by H plus at the other side. So which means that we are going to add 8H plus to the other side plus 8H plus. Now let's move to equation 2, which says Br O minus gives Br minus. Now what do we do here? Let's check the central atom. Bromine is balanced, so we don't need to balance it. So we have oxygen here, then we have 1 atom of oxygen here. We are going to balance it with 1 mole of water at the other side, so which means we are going to add plus H2O. Now here we have 2 hydrogen atoms, so which means we are going to balance it by 2H plus at the other side. So it will become Br O minus plus 2H plus gives Br minus plus H2O. Now we've balanced the 2 equations atomically. The next step is to balance each equation electrically. Balance each equation electrically. So for the first half equation, we have Cr3 plus 4H2O gives CrO4 2 minus plus 8H plus. To balance this electrically, we are going to calculate the number of charges at the left hand side and make sure it's equal to the number of charges at the right hand side. So at the left hand side, we have a total of +3 charge. Water is neutral, so it has no charge. At the left hand side, we have -2 plus 8 times 1. You know, this plus is +1. 8 times 1, that's 8. So -2 plus 8, that's +6. So here we have +3, here we have +6. So we have to add electron to one side of the equation, and remember that electrons are negatively charged, which means that we have to add electrons to the side that is more positive to reduce it to +3. So how many electrons are we going to add? We are going to add 3 electrons to the right hand side, because +6 minus 3 will give us +3. +6 minus 3 will be equal to +3. So which means we are going to add 3 electrons to the right hand side. Gives CrO4 2 minus plus 8H plus 3E minus. 3E minus. So let's balance the second equation electrically. BrO minus plus 2H plus gives Br minus plus H2O. Now, what do? We are going to find the number of charges. At the left hand side, we have -1 plus 2 times +1, that's +2, and that is +1. At the right hand side, we have a total charge of -1 because water is neutral. So which means here we have +1, here we have -1. In order to lower this +1 to -1, we need to add 2 electrons because electrons are negatively charged. So +1 minus 2, that will give us -1. So which means we are going to add 2 electrons. We are going to add 2 electrons to the right hand side. Plus 2 electrons gives Br minus plus H2O. Okay, so now let's bring the 2 equations together. Equation 1, Cr3 plus 4H2O gives CrO4 2 minus plus 8H plus 3E minus, and equation 2, we have BrO minus plus 2H plus gives Br minus plus H2O. So we have to, plus H2O. Oh, sorry, we skipped plus 2E minus here. So we have to make sure that the number of electrons are equal so that we can cancel out the number of electrons. So how do we do that? We can multiply equation 1 by 2 and multiply equation 2 by 3 such that the number of electrons will be 6 for both equations. So you multiply equation 1 by 2 and equation 2 by 3. So if we multiply equation 1 by 2, that will be 2Cr3 plus 8H2O gives 2CrO4 2 minus plus 16H plus 6E minus. Then equation 2 will become 3BrO minus plus 6H plus 6E minus gives 3Br minus plus 3 times 1, that's 3H2O. So now we have 6E minus at the right hand side here, and we have 6E minus at the left hand side here, so we can cancel them out and then combine equation 1 and 2. Combine equation 1 and 2. So if we combine equation 1 and 2, we are going to combine the left hand side of the equation and then combine the right hand side of the equation. So that will give us 2Cr3 plus 3BrO minus plus 6H plus 8H2O gives 2CrO4 2 minus plus 3Br minus plus 3H2O plus 16H plus. Okay, so now we can cancel out some common ions at both sides of the equation. If you look at it, here we have 6H plus, here we have 16H plus. So if you remove 6H plus here, subtract 6H plus from 16, that will remain 10H plus here. Also, we have 3 moles of water here, we have 8 moles of water here. If we remove these 3 moles of water, subtract 3 from 8, then we'll be left with 5 moles of water here. So the equation becomes 2Cr3 plus 3BrO minus plus 5H2O gives 2Cr O4 2 minus plus 3Br minus plus 10H plus. Now this equation is supposed to be balanced. This is supposed to be our net ionic equation if we are working in acidic medium, but because we are working in basic medium, then we have to follow step 4. Step 4 says that in basic medium, check the number of hydrogen ion present and add the corresponding number of hydroxide ion to both sides. So how many hydrogen ions do we have? We have 10 H plus, so which means we are going to add 10 OH minus to both sides of the equation. Add 10 OH minus to both sides of the equation. So if we add 10 OH minus to both sides of the equation, we are going to have 2Cl3 plus 3BrO minus plus 5H2O plus 10 OH minus gives 2CrO4 2 minus plus 3Br minus plus 10H plus 10 OH minus. Okay, now we know that 10H plus OH minus will give H2O. That's water. Hydrogen ion plus hydroxide ion will give us water. So 10H plus 10 OH minus will give us 10H2O here. So we can have 2Cr3 plus 3BrO minus plus 5H2O plus 10 OH minus gives 2Cr O4 2 minus plus 3Br minus plus 10H2O. But we can reduce the number of water we have. We have 5H2O at the left hand side, we have 10H2O at the right hand side. So we can cancel out 5H2O here. If we remove 5 out of 10H2O here, we'll be left with 5H2O. So the equation, we can now say that the net ionic equation should now be equal to 2Cr3 plus 3BrO minus plus 10 OH minus gives 2CrO4 2 minus plus 3Br minus plus 5H2O. So this is the net ionic equation. Let's confirm if the number of charges are equal at both sides of the equation. Here we have 2 times 3, that's plus 6, 3 times minus 1, that's minus 3, 10 times minus 1, that's minus 10, plus 6 minus 3 minus 10, that is equal to minus 7. Yeah, minus 7. At the right hand side, we have 2 times minus 2, that's minus 4, 3 times minus 1, that's minus 3, it's also equal to minus 7. So which means that the equation, the redox equation, is balanced. Please don't forget to like, share and subscribe to our channel. Also leave a comment. If you want us to teach a particular topic, please mention it in the comment section. Thank you very much. Have a good day.